Everyone, so today's problem of the day is maximum element after decreasing and rearranging. And what is given in description? You are given an array of positive integers ARR. Before perform some operations, possibly none or ARR, so that it satisfies these conditions. And what are the conditions? The value of the first element in ARR must be 1. The absolute difference between any two adjacent element must be less than or equals to 1. In other words, the absolute difference of ARR I minus ARR I minus 1 should be less than equals to 1. For each I, where I can start range start from 1 till array length, absolute of S is the absolute value of X. There are two types of operation that you can perform any number of times. First is to decrease the number of to decrease the value of any element of ARR to a smaller positive integer and rearrange the element of ARR to be in any order. We need to return the maximum possible value of an element in ARR. So we will be giving some ARR array and suppose it will be having some value like 1, 2, 10, 12, something like this. And we need to find the maximum possible value in this array after performing the operation. What are the operations? We need to convert this array into an array such that this this all elements are in the absolute difference between any two adjacent element can be maximum 1. So we can change it to 1, 2, 3, 4. So in this way, we can get, because we can do, we can rearrange the element and we can decrease to any smaller value. So to 4 we can decrease to 2, 10 we can decrease to 3 because 3 is a smaller value than 10, and then 12 we can decrease it to 4. And in this case, we can get the maximum value 4 and we can return 4 in this. So if we will see the constraint is the array length can go maximum till 10 to the power 5 and the value can go maximum till 10 to the power 9. And if to understand better, if we will see the first example, the first example is 2, 2, 1, 2, 2. So in this case, if we will see this array is already a valid array because if you will see the difference between any two adjacent value is not exceeding 1. And it is always less than equals to 1, and we can't make the value more than 2 also. The maximum possible value can be 2 only in this case. Why we can't make value greater than 2? Because if we have the larger number, suppose 10, then we can convert that number to some value like 9, 8, 7, 6 or something. But the smaller value, we can't increase the value to 3 or something. Only the larger value we can convert to smaller value. So in this case, we can get the maximum possible value will be 2 only. We will see the second example. Second example is 100, 1 and 1000. So in this case, we will see to 1 be first element can always be 1 only. So 1 is fine. Then this we can arrange. So we will shift this 1 to here. So first we need to sort the element. In this example, we can say that we need to sort the element because we need 1 at the starting position. If we will not sort the element, if we will directly see, suppose we have not sort the element. So 1 is here. So we can change this to 2, and we can change this also. We need to change to 2 only because we can't change it to 3 because the adjacent value we need as an adjacent value difference we need should be less than equals to 1. So we can't increase it to 3. So the maximum possible value in this case will be 2. So so if we will rearrange it first because we have two operations. First, we can rearrange any element, and second, we can decrease the value to maximum to the minimum of that current value. So if we will first rearrange it, so 1 is fine. Then 100 we can easily change to 2. And this we can easily change to 3, and 3 we can get the maximum possible value. The same thing we will do in our solution. First, we will need to sort the element, and first element will always be 1. So we don't have to worry about the 0th index element. We will go directly with the index value 1. So index value 1, we will try if we can increase these value than the before value. The same thing I have done in the solution. Solution mein I initialized my array length, and then first time sorting my array. then initially my answer will be int ARR equals to 1. Why I have declared my answer as 1? Because first element will always be 1. So we don't have to worry about this. Our minimum possible answer will be 1 only. Then if we will go, we will start from first index till n minus 1th index. So we will see if our array value, if it is greater than answer plus 1, because 1 we already have. So we will see if we will increase 1, then if that current value, if it is greater than equals to this value, that means we can, if it is greater than equals to, if it is equals to answer plus 1, then don't need to do anything. We can simply do answer plus plus. But if it is greater than answer plus 1, then we have the option to decrease this value. So we can decrease this value to answer plus 1, and we can do answer plus plus. And at the end, we can return our answer. Hope you are able to understand. I am doing this short because in this way, we can easily we can easily maximize our answer, and we can try to make a sequence in increasing order. This way, we will be able to achieve the maximum value easily. So yeah, that's it. If we will see the time complexity is big of n, and space complexity big of n log n, because we are doing this short using this short function, which will take n log n time complexity, and space complexity will be big of n because big of 1, because we are not using any extra space, so it will be constant. So this question we are easily able to solve with the help of greedy approach. If we will try to do with some algorithm, or if you will think about some algorithm, it can go even like tough also, and it can be the hard also. But if we are going with the greedy approach, we can easily solve it, because we just need to check that we first need to sort an element, and then we will try to make it the increasing sequence. In that case, we are able to achieve that maximum value easily. So yeah, that's it. If you have any queries, you can reach out to me in the comment section. I will try my best to answer all your queries there. So yeah, thank you.